Hello and welcome to the Stardog Academy training on security. This is Stephen Nowell, Director of Technical Support at Stardog. To let you know a little bit more about me, I've been with Stardog for over 8 years and served various roles during my time here. I have a BS in Computer Science with a minor in Spanish, and I live in South Central Pennsylvania with my wonderful wife and son. Today I'm going to walk you through Stardog's security model in detail. During this training session, you will learn Stardog's role-based access control implementation, how to create new users and roles assigning permissions to each, the specifics and unique qualities of named graph security, the basics of LDAP integration, and how to understand the requirements for running Stardog with SSL. Let's get started. This section is about getting started with security in Stardog. Stardog's security implementation is based on Apache Shiro and allows for several different methods for both authenticating users and authorizing them to perform tasks. The 3 styles of authentication include basic username and password, as well as integration with both LDAP and Kerberos systems. For authorization, Stardog implements a role-based access control model. At its heart, this means that specific permissions are applied to various roles in the system, and then individual users are given combinations of those roles to determine their overall effective permissions. These work together to create access control lists, or ACLs, for individual databases and their metadata, specific name graphs within those databases, and administrative commands. Out of the box, Stardog uses a default basic username and password system for authenticating users. Stardog manages these user accounts and hashed passwords internally. Users and roles are granted access to specific system resources, and administrators can explicitly disable and re-enable users. Basic password requirements, such as minimum and maximum length, can be set at the server level, and a regular expression can be provided to enforce specific character rules, like requiring or disallowing numbers and symbols. When delegating authentication to an external LDAP or Kerberos system, Stardog no longer manages user accounts. It instead uses specific system properties to retrieve the user information and role membership directly from the LDAP or Kerberos server. Stardog does, however, continue to manage the specific permissions that given users and roles have on system resources, as this falls under authorization. Here we have a simple example of integrating Stardog with an LDAP server for authentication. On the left, we have sample entries from the LDAP server itself, and on the right is a section of the stardog.properties file located in Stardog Home. Managing an LDAP server is external to Stardog and therefore outside the scope of this training video. However, the 6 LDAP entries shown here all have specific meaning to our Stardog instance. The bottom 3 blocks are typical definitions of users within LDAP. Here we have 3 users being defined: Superuser, Hank, and Beth. Take note of the DNs, or distinguished names, of each. Looking on the right-hand side, we can see that the DNs of these 3 users match the ldap.user.dn.templates that we've defined. These templates tell Stardog how to map an LDAP DN to a Stardog user. Noting the zeros within curly braces, we can know that the UID portion of each user's DN is what will become their Stardog username. The top 3 blocks of the LDAP entries show LDAP groups: Stardog Superusers, Stardog Modelers, and Stardog Readers. Each one contains one member that is the DN of one of the users. In the stardog.properties file, we define ldap.superusers.group to be the DN of Stardog Superusers. And then within ldap.role.mappings, we map the Stardog Modelers DN to the Stardog Role Modelers, and the Stardog Readers DN to the Queriers role. At this point, we could go inside Stardog and define permissions for those Modelers and Queriers roles, and the permissions would be applied as specified to our 3 users. The Stardog documentation goes into much more detail about this specific example, and about the various Stardog properties settings that can be used. To integrate Stardog with a Kerberos server, you simply need to set a few properties inside the stardog.properties file. Most notably, you need krb5.keytab to point to the keytab file generated for your server, krb5.admin.principal to specify the Kerberos principal to act as the administrator, and krb5.user.translation.regex to tell Stardog how to translate a Kerberos principal into a Stardog username, which is specifically helpful when the principal names contain characters like / that are not acceptable in Stardog usernames. When using a Stardog cluster, the pack.krb5.principal and pack.krb5.keytab properties are also needed to allow cluster nodes to authorize directly with one another for internode communication. Much more detail on setting up Kerberos authentication can be found in the Stardog documentation. As I stated earlier, authorization happens by granting permissions over specific resources to users and roles. It is worth noting that while granting permissions explicitly to individual users is allowed, we highly encourage the use of roles as much as possible. With permissions assigned to roles, you're able to grant batches of related permissions to a user all at once. This allows for considerably easier onboarding, offboarding, and repositioning of users within the organization. It also lets you more easily know at a glance what permissions a given user has, simply by looking at that user's assigned roles. In Stardog, a permission is defined as a subject being granted an action over a specific resource. The available actions are create, read, write, delete, grant, revoke, execute, and all, and the available resources are database, user, role, admin, metadata, named graph, virtual graph, data source, and ICV constraints. Any action can be granted over any resource. However, some of the possible combinations are meaningless and therefore will provide no actual permissions. This concludes the section on getting started with security in Stardog. This section is a demo on creating users and roles in Stardog Studio. To follow along with this demo, you will need a running Stardog server and login credentials for a Superuser. From the main Stardog Studio page, after you've logged into your server, click the lock icon on the left to enter the security section. Here you will see a list of all the users and roles currently in the system. To add a user, click the plus sign at the top of the users list. Then enter the new username, a password, repeat the password to confirm, and click Add. Now the user shows up here in the list. To add a role, similarly just click the plus sign at the top of the roles list, enter the new role name, and click Add. This concludes the demo on creating users and roles in Stardog Studio. This section is about security permissions in Stardog. In Stardog, a permission is made up of three parts: the subject, the action, and the resource. You can read them as subject can perform action over resource. Subjects, which are not shown in these examples, are always either a user or a role, and the resource consists of both a type and a name. Sometimes this name can be a wildcard, like in the case of create database star. Sometimes it's a specific name, such as in read database mydb. And sometimes it's a compound string, like in the case of read named graph mydb / and then a graph URI. We will cover these cases in more detail as we go forward. This table shows all of the available combinations of actions and resource types, and which ones produce meaningful permissions within Stardog. It can be found along with any updates in the Stardog documentation. However, in this video we will go action by action to provide detail on what all of these combinations allow. We start with the create action. For a given resource type, database, user, role, virtual graph, or data source, assigning the permission create, that type, and star allows the subject to create instances of that resource type. It is worth noting that create, type, star is specifically the required permission. Something like create database mydb would not allow the subject to create a database specifically named mydb. They would need the wildcard. When a subject has the create virtual graph star permission, they're able to create new virtual graphs as you would expect. However, in order to create a virtual graph with a given data source, the subject would also require read access on that data source. To create a virtual graph with a private data source, the subject would need create data source star, and in order to update a virtual graph after it has been created, the subject would require delete permission on it, because updating a virtual graph is executed as a drop and recreate. We start with the create action. For a given resource type, database, user, role, virtual graph, or data source, assigning the permission create that type star allows the subject to create instances of that resource type. It is worth noting that something like the permission create database mydb would not allow the subject to create a database specifically named mydb. Create database star is specifically the required permission. When a subject has the create virtual graph star permission, They're able to create new virtual graphs as you would expect. However, to create a virtual graph with a given data source, the subject would also require read access on that data source. To create a virtual graph with a private data source, the subject would need create data source star. And in order to update a virtual graph after it has been created, the subject would require delete permission on it, because updating a virtual graph is executed as a drop and recreate. The read action mostly does what one would expect, providing read access to the various resources. Read on a database will cause it to appear in the list of databases, and give full query access, minus whatever named graph security restrictions may be on the database. Without read access to a database, the subject will be unable to see that said database even exists. Read on a database also grants the subject read access to its bytes document store. Read on a user causes the user to appear in the users list, and allows the subject to see its enabled status, permissions, and role assignments. Read on a role causes it to appear in the roles list, and allows the subject to see its effective permissions. The read action on type metadata with a database name allows the subject to read that database's properties and settings. When named graph security is enabled, read permissions on named graphs can be granted. When specifying a named graph, you need to first specify a database, then a backslash, and then the URI of the named graph. Wildcards do not work on named graph permissions. Everything must be explicit. Note that the subject would also need read permission on the database itself in order to see the named graph within it. Read on a virtual graph causes the virtual graph to appear in the list of virtual graphs, and allows the subject to query it, see its options and mappings, and generate the data model. Read on a data source causes the data source to appear in the data sources list, and allows the subject to create a virtual graph backed by it. Finally, read on the ICV constraints of a given database allows the subject to see that database's constraints when using integrity constraint validation. The read action mostly does what one would expect, providing read access to the various resources. Read on a database will cause it to appear in the list of databases and give full query access, minus whatever named graph security restrictions might be on that database. Without read access to a database, the subject will be unable to see that said database even exists. Read on a database also grants the subject read access to its bytes document store. Read on a user causes the user to appear in the users list, and allows the subject to see its enabled status, permissions, and role assignments. Read on a role causes it to appear in the role list, and allows the subject to see its effective permissions. The read action on type metadata with a database name allows the subject to read that database's properties and settings. When named graph security is enabled, read permissions on named graphs can be granted. When specifying a named graph, you need to first specify a database, then a backslash, then the URI of the named graph. Wildcards do not work on named graph permissions. Everything must be explicit. Note that the subject would also need read permission on the database itself in order to see the named graph within it. Read on a virtual graph causes it to appear in the virtual graphs list and allows the subject to query it, see its options and mappings, and generate its data model. Read on a data source causes it to appear in the list of data sources and allows the subject to create a virtual graph backed by it. Finally, read on the ICV constraints of a given database allows the subject to see that database's constraints when using integrity constraint validation. Write permissions are also fairly intuitive. Write permission on a database allows the subject to perform Sparkle update queries and other update operations via the Snarl or Java API. The subject is also able to add, remove, and clear documents from that database's bytes document store. Write permission on a user allows the subject to change that user's password. Write on a database's metadata allows the subject to modify that database's properties and settings, as well as add and remove stored queries for use against that database. Again, with named graph security enabled, write permission gives the subject write access to that graph, allowing them to perform Sparkle update queries on it. Note that, like read, the user would also need write permission on the database itself in order for this to take effect. Write on a database's ICV constraints lets the subject modify and delete integrity constraints from that database. Delete permissions are similar to create permissions, where the delete resource type star permission allows a user to delete instances of a specific kind of resource. However, unlike create, explicit resources, databases, users, or whatever can be specified instead of having to grant all or nothing delete access. When paired with create for virtual graphs and data sources, the subject is able to update. Grant and revoke work very similarly and allow a subject to add or remove other subjects from the ACL of a given resource by adding or removing permissions from the subject. The catch is that grant permission works if and only if the user doing the granting has the exact permission that's being granted. Here's an example. User A has read permission on a database called MyDB, and also grant permission on MyDB. This would allow user A to add read permission on MyDB to a user B or a role C. If user A attempted to give write permissions, however, that action would be denied because user A does not themselves have write permission on that database. Revoke does not have this caveat, so a subject with revoke permission on a resource can revoke any permission regarding that resource from any other subjects besides superusers. Finally, the execute permission has two very specific uses. If a subject has execute permissions on a given user, then that subject can execute commands while impersonating that user. This is useful in cases where, for example, a service account would need to act on behalf of a different user so that that user's permissions are taken into consideration. It is also useful for administrators to test their security setup by seeing what a regular user would see in a given circumstance. Execute on admin isn't technically valid. The resource type here is actually DBMS admin. DBMS admin does not, as of the time of this recording, appear in Stardog Studio, so therefore it would need to be set via the CLI's Stardog admin role grant and Stardog admin role revoke commands. However, these actions are generally performed by superusers, so it is perhaps less important to explicitly be able to grant them to other subjects. Execute on DBMS admin of a database allows the subject to verify, optimize, offline, or online the database. Execute with type DBMS admin and the resource name shutdown allows the subject to issue a remote server shutdown command. Read and write permissions with type DBMS admin and the explicit name set-property allows the subject to read or update server or system properties, respectively. Certain actions have no specific permissions check and can only be performed by a superuser. These include all cache management operations for a cluster, enabling or disabling users, viewing a role's permission to which your user is not assigned, viewing the list of users assigned to a given role. Note that the other way around, viewing a user's list of roles, only requires read on that user, converting superusers into regular users, and opening connections based on another user's transaction. This concludes the section about security permissions in Stardog. This section is a demo on assigning roles to users. To follow along with this demo, you will need a running Stardog server and login credentials for a superuser. From the main Stardog Studio page, after you've logged into your server, click the lock icon on the left to enter the security section. Here you will see a list of all the users and roles currently in the system. Click on the user to whom you would like to assign a role, and click Assign Role in the upper right. Click on each role that you wish to assign. Finally, X out of the pop-up, and the user has the requested role assignments. This concludes the demo on assigning roles to users. This section is about named graph security. By default, named graph security is not enabled for a database. It must be explicitly enabled via the security.named.graphs configuration option. When enabled, users receive Sparkle query results only from the named graphs to which they have read access. Likewise, without write access to a specific graph, the subject will be unable to add triples to that graph, regardless of whether or not it already exists in the database. If a user has read access to a database but not read access to any of its named graphs, and named graph security is enabled, the database will appear to them as empty by default. There is a server configuration option to interpret an empty set of graphs to mean access to all graphs, but it defaults to off. It is important to note that when named graph security is enabled, in order to query a virtual graph, a subject will need read permission on the special named graph consisting of virtual and the virtual graph name, on top of read access to the virtual graph itself. This is because the Sparkle syntax required to query virtual graphs involves querying this special named graph, which triggers named graph security. This concludes the section about named graph security. This section is a demo of named graph security. For the purposes of this demo, I've taken our music database and moved all of the songwriter information into its own named graph, urn:\writers. Now I'll head into the security section and create a new role. We'll call it CanCWriters. To that role, we'll add one permission, giving it read access to our named graph within the music database, urn:\writers. Before I do anything with this role, I'm going to sign in as our new user up here that doesn't have this role assigned to it. And we're going to run this query. It's This query looks for the tracks of the album Abbey Road, gets their name and description, as well as the songwriter. But for the sake of the demo, I've put writer inside of an optional block so that we can see results even if we don't have a writer. As you can see when I run the query, we get everything for the tracks except writer information because our user doesn't have access to that named graph. So it appears to our user as an empty graph, and we can't see the writer information. However, if I go back in as admin, go up to our user and assign him the Can See Writers role, I would be able to log back in as the new user and rerun the query and get our writer information. This concludes the demo of named graph security. This section is about using SSL with Stardog. By default, a Stardog server is set up for HTTP communication only. This is fine for development, but in most production environments, SSL is a necessity. Stardog uses the standard Java conventions for setting up SSL communication. You will need a .jks key store containing a valid SSL certificate for your Stardog server, and a .jks trust store that contains that same certificate. When setting up your server, you will need to add the standard Java SSL store properties, either to the stardog.properties file in your Stardog home, or to the Stardog server Java args environment variable in the shell environment from which you are starting your server. These settings are javax.net.ssl.keystore, which contains the absolute path to your .jks keystore, and javax.net.ssl.keystore password, which contains the password to that keystore, if any. Once this is set up, you will need to modify your server start command wherever it's run, whether that's manually or performed by systemd, to include either the enable SSL flag or the require SSL flag. Enable SSL starts your Stardog server with HTTP listening on one port, defaulting to 5820, and HTTPS listening on the other, default is 5821. These ports can be specified with the port and SSL port flags. Setting require SSL only opens the HTTPS listener on the default port of 5820. To set up your Java command line client to use SSL, you'll need to set the appropriate Java arguments inside of the Stardog Java args environment variable. Those arguments point to your .jks trust store very similarly to the key store, and they are javax.net.ssl.truststore and javax.net.ssl.truststorepassword. You will also likely want to set the stardog.default.cli.server argument inside of your Stardog Java args to point to this HTTPS endpoint. Otherwise, you'll need to type the entire HTTPS address into every command you run. When using Stardog Studio from a web browser, you simply need your browser configured to trust the server's SSL certificate. This concludes the section about using SSL with Stardog. This concludes the Stardog Academy training on security, where we covered Stardog's role-based access control implementation, how to create new users and roles assigning permissions to each, the specifics and unique qualities of named graph security, the basics of LDAP integration, and how to understand the requirements for running Stardog with SSL. Thank you for following along. If you have any questions, please review our frequently asked questions page or visit our documentation for additional information.